Welcome to the Software Engineering channel on YouTube. Today we're going to go over control structures, specifically conditionals and loops. There's an old joke. The programmer's wife sent him to the grocery store with the instructions to get a loaf of bread, and if they have eggs, get a dozen. He comes home with a dozen loaves of bread and tells her they had eggs. This joke might sound silly to somebody who's not a programmer, but to a programmer who, this is a very important lesson. Understanding how control structures work and where they are necessary is key to understanding how to control the flow of the program. So what are they? The most basic form of a conditional statement is the if statement. If, and in its expanded versions, if else and if else if else, allow certain statements to run if and only if the condition is true for each particular bracket. The ternary operator is a shorthand way to write if else. We mentioned that previously in, I think it was the second video. We'll look at more examples of that here today. This is useful when you want to do things in line. Switch statements are useful when you want to test the value of an integer type. They can only be used for integer types in C++. And perform different operations depending on what that value is. And finally, we have TryCatch statements, which are a more advanced form of control statement. A lot of times, books will leave them for later. I'm going to go ahead and introduce them now because they are important. If anything in the try block is going to try and execute, if everything succeeds, it will move on. If an exception is thrown at any point during that try block, it will jump to the appropriate catch statement. These are useful for preventing exceptional cases from crashing your program by ensuring that your program has appropriate methods for dealing with those exceptional cases. Things like divide by zero errors or lost connections, things that aren't meant to be the normal course of business but which can happen. You don't want your program to crash when they happen. So here's the basic structure for a simple if statement. You have the if keyword, and in parentheses you have your condition or conditions. And then if you do not have the curly brackets, only the next statement below the if will be included in the if condition. If you include the scope, everything within the scope will be handled under the if condition. Moving on to if else, very similar structure. You can have your if, you have your if keyword, your condition or conditions. If everything in this condition block is false or evaluates to false, then the else block will get run instead. Finally, you have if else, very similar, where you can have conditions up here for your normal if statement or your normal if condition. If that's not true, it will move on and test against the else if and check those conditions. If that's not true, and you can have multiple else ifs, if all of those evaluate to not true, then the else block will get run. The ternary operator, as I mentioned, is a shorthand. You have the condition, you put the question mark here. If the condition is true, then the statement if true block gets run. Otherwise, the statement if false block gets run. Some places that you might see this used are if you need to do an assignment, or if you want to do output and you don't want to have multiple lines and where you're copying and pasting the same string and replace it one value only. You can consolidate it into a single line and use the ternary operator. Switch is a somewhat more advanced form of the if, where it allows you to group conditions. The condition here is going to be a value. So it's going to be some sort of an integer value, and it's going to test if the integer value equals each one of these cases. So you'll have value equals whatever case 1 is, so let's say it equals 0, then 1, 2, and then it would do whatever the appropriate thing is. Note with switch statements, you have to break out of the case. If you do not break, it will execute the following case as well. So in this example, case 1 executes and then it will break out of the switch statement, meaning it will jump out and won't execute anything else in the switch and will continue outside of it. But if case 2 gets run, there is no break. So then case 2 would run, and then when it's finished do something 2, it would then run case 3 before it breaks. That's an important distinction that you want to keep an eye on. And as I mentioned, TryCatch, everything that is in the try block is going to attempt to get run. If an exception happens, it's going to get thrown, and it'll jump to whatever catch block catches that exception type. You can throw multiple different types of exceptions, and if you are using a TryCatch, you should try and catch all of the exception types that can be thrown in the block of code that you're running. The other type of control statement that we want to look at is loop statements. Loop statements repeat operations multiple times based on testing a condition. The most common is a for loop, where you provide an initial state, you give it a condition to check every iteration, and you perform an operation at the end of each iteration, usually some form of increment or decrement. While loops will execute as long as the provided condition is true. Note that this means the loop will not run the first time if the condition starts as false. Do while will execute the loop once and then test it at the end of the loop, and will continue as long as the condition is true. Note the difference between while and do while is while will test it first and then execute, do while will execute first and then test. And finally, I'm going to mention this only for completeness, but I'm not going to even provide an example because you should never use it. Goto statements can be used to create loops. Goto is a keyword that's there for backwards compatibility with C. However, as I mentioned, you should never use it. Just know that it's there, so if you see it, don't be surprised in somebody in legacy code. But again, avoid it at all costs. So here's a structure for a for loop. You have your starting point, your condition, whatever is going to happen on the iteration, and then each iteration you're going to do something. A while loop, similar structure. It looks a lot like an if block, except it's going to continuously execute. And do while, the while gets thrown at the bottom, and note that there's a semicolon after the while. That's important, as it will cause problems and give you compiler errors if you forget it. But again, the do will execute this the first time, and then it will test the condition afterwards. So if the condition is true, it will continue executing. If the condition after it executes the first time is false, it will stop executing, meaning it will execute once and only once. If it's true, it will continue executing until the condition is false. So with that, let's jump into some examples. Right, so here we have a very simple example for entering a magic number. You'll notice that I create a magic number. This is hard-coded just because this is a very simple example. And I'm going to ask the user to provide a number. If they guess the magic number, it's going to output you entered the magic number, and then it'll execute. If they did not guess the magic number, then the program will just exit. So compiling it again. Right, so just to show you that what happens if I don't enter the magic number, as I say, it just exits. If I do enter the magic number, boom, we get the magic number. Right, so moving on to the next example. This is the if-else example. Here we'll look and see, we're going to test this, do a similar thing, but we're going to test to see if it's an even number or an odd number. Alright, so if we enter a number, let's say we enter 3, it's going to say you entered an odd number. If I enter 6, I entered an even number. So I enter anything that's divisible by 2. Note that here I'm using the modulo operator. We briefly covered that when we did the introduction, but this comes into handy, especially later when we get to more advanced mathematics that we can do with the language. This is an easy way to test if a number is even. If it's evenly divisible by 2, it'll return 0 as a remainder, so that would mean it's an even number. Otherwise, it's going to return 1, so you end up with an odd number. moving on to a if-else example. So here I've created an enumeration. So this is an example of how to use the enumeration type. What this does is I'm creating a integer alias. Sunday is going to be 0, then it's going to increment automatically. So Monday would be 1, Tuesday 2, Wednesday 3, etc. Here I'm going to ask the user to provide input. I'm casting it just to make sure it stays type safe, but that's not entirely necessary because the enumeration itself will treat it like an integer. And then I'm going to have various outputs based off of what day you put in here. Try to use the verses from Sunday Fun Day, the oldie song. However, it only had Sunday, Monday, and then getting around to the weekend again. So if we come in and go so if we enter something off the wall, it's going to come down and jump into the else block where we say, hey, you didn't enter a real day. If I pick another day, it's going to give me whatever was for that. So in this case I said Thursday, so it said almost a weekend. Notice that it skipped over all of the other conditions and went straight to this one. So it evaluated the condition, it was false, 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 it got to this one true, and stopped executing this block and then jumping out of the loop and then returning. I'm going to skip over to the switch one because this uses the same example. So here again it's the exact same thing we just did with the if-else, but notice because it's an integer type I can use a switch statement instead, and it cleans up some of the unnecessary checks. I can just put case and then put the value that I'm checking. So I pass in the value in the switch statement, and then it will check if day equals this, day equals this, day equals this, and note that the break, so when it executes Sunday Fun Day, it'll put the output, it'll break, which means it jumps all the way out of the switch and will execute whatever statement comes here. In this case it's return 0. If none of these conditions up here execute properly, it will execute the default. This is basically your else block, and then after that we'll then exit the switch. So just to show you the previous example, those same two values that I did in the previous one, you get the same results. And if I do something else, it also gets exactly what we'd expect. Just to show you what happens is, say I comment this breakout. So if I now put 0, notice that it executes what's in Sunday as well as what's in Monday. Without the break, it's going to fall right into the next case. What this allows you to do is if you have multiple cases that need to get run, or in this case if I wanted to run both of them together like this, you can group them so that you can test multiple things instead of having the code copy and pasted. You just have multiple checks, and then when it gets to, down to the portion of code you want run, it's all right there. Alright, so jumping back to the TryCatch. This one's a little more advanced than what we've seen so far, so I'm going to kind of walk through it. I've created a function here, and we'll go over functions in more detail here in another lesson or two. We have a return value, the name of the function, and then it takes the parameters. I'm giving it two integer parameters, a numerator and a denominator. And then what I'm doing, I'm checking to make sure the denominator is not 0. If it is 0, I'm going to throw an exception that says divide by 0. Otherwise, I will return the value of n divided by d. So here, we get I'm going to ask the user to enter the appropriate integers, and then I'm going to actually start my try-catch. Note that in the try-catch, I call the function. I can put the input here because inside this try-catch block, the result is declared inside the try-catch block, so it's not valid outside. If I wanted to execute this cout statement outside of it, I would need to move the declaration of result outside of it. However, in this particular case, it wouldn't make much sense to try and output outside of the catch. So you want to evaluate what makes sense to move outside the try-catch and what doesn't. Typically, you want to try and keep your try block as thin as possible. But if things don't make sense to move out because, for example, result would be junk if divide didn't happen, then keeping it inside makes more sense. If the exception gets thrown, I put out the exception, stating what it was, and then let the program exit normally. So we're going to start with actually forcing the exception. You'll notice that it says divide by 0. And if I divide it by, or give it a valid divisor, it will actually give me a valid result. So when I divided by 0, that got thrown. So this got executed instead of this. And we'll go into exceptions in more detail later, but I did want to introduce the concept because this is a control structure itself. All right, and finally we're going to look at the ternary control structure. As I mentioned earlier, it's a shorthand. So this is very similar to the even-odd example we looked at earlier, but you'll notice that there's no if block, so this is a single line output. Instead of where I'm saying even or odd, I replaced it with testing the number and then providing a string of even or odd depending on what the output of this test is. Note that my code is much smaller than the earlier example. So if I enter 4, I say enter an even number, enter, let's say 9, oops, and I enter an odd number. Same results we would have got with the other one, but again, the code is smaller and more concise because I put this in line. And the last thing we're going to look at today is loops. And for this, I did a single example that has several different types of loops in it, so we'll walk through each one. Again, I declared a function here, and then, like I said, we'll go into functions in more detail later, but we have a return value. This is a Boolean type, so it's going to be true or false. The function name, and I'm going to take an unsigned integer because we don't want to worry about negative numbers, and we'll go from there. So we're going to cap our loop here. So we have a cap that I'm declaring, and I'm going to stop at the square root of whatever number was passed in. So I'm going to start at 2 because 0 and 1 by definition are not prime, and I'm going to stop when I reach the cap, the square root of whatever number was passed in, and I'm going to check all of those values. If any of those values are evenly divisible, then that number is not prime. Otherwise, once we get through the entire loop, we would execute true because we found a prime number. So here I've also, if you recall, I introduced the array class, or the array template class, in a couple lectures ago. So here we're going to go ahead and I'm hard coding just an example of 10 numbers. So I want to show the while condition. So while the current size of the array is less than the array size, I want to continue executing this code. So I'm going to have a temporary variable that I'm using here. I'm going to call it num. And then I'm going to ask the user to enter the number. This is a way of doing error checking when you're doing console input. Enter the number, and then if the stream comes back in a valid state, then I can enter a number. I actually probably should clear out the stream if it came out in a negative state, but just wanted to demonstrate the loop here. This is the starting point of what you would look at for error checking on console input. Assuming that everything goes through properly, then I would insert that into the array. And finally, once I've got all of the variables, or all the values that I want to check in the array, I'm going to do a for loop on the array and go through and check if each one is prime. So here we've got a while loop, a do while, and a for. We also have a for up here. So let's see how it goes. Alright, so I gotta enter 10 numbers here, so let's start with, we'll start with 2. So here you got, it goes through each one of these. 2 is prime, 3 is prime, 4 is not, 5 is, 6 is not, 7 is, 8, 9 are not, 10 is not, 11 is, which is what we would expect to see. And with that, that concludes today's lecture. And like I said, in the next couple lectures, we'll start getting into functions and classes. So, see you next time.